Hey everybody, this is 4.4, deciding a method. Okay, so far we've talked about how to solve using factoring, using square roots to solve, or complete the square. So these three methods are great ways to do it. Some maybe are a little easier, some maybe are a little harder. And that's why we're going to talk about them and decide like when we can use them, because we don't want to spend a lot of time trying to try a method when it doesn't actually work. Okay, so let's first talk about factoring. Factoring is a great idea. I feel like it's probably the quickest, but it doesn't always work. So with factoring, I'd always maybe start with that and then see what else we could do if it doesn't. So factoring, we always need to figure out, are there two things that can multiply and add? Okay, that's kind of like after we do the glasses. So maybe I'll draw that just to remind you. Okay, do not spend more than 60 seconds trying to find the two things that multiply and add. Because chances are maybe it's not factorable, and I don't want you to spend 10 minutes or 30 minutes trying to do a problem that you have to use a different way to do it. Okay? Alright, next we have is using square roots to solve. This works well when there's already just one x in your equation and it's being squared. So like here's an example. Okay, 9x squared equals 4. This would be a great example. We have 1x, it's being squared. Okay, you can also find something that looks like this. Something like that would be another example. There's only 1x in that equation, and it's being squared. Okay, and then completing the square, that works really well if a is 1 and b is even. It probably takes a little bit longer than factoring, so again, see if you can factor first. But everything that can be factored can also be done using the complete the square. So I guess completing the square so far always works, but there will be some situations where we'll have one more method that we haven't talked about that would probably want to do instead of completing the square if it gets really hairy. Okay, so complete the square when a is 1, b is even. Again, a and b and c are just like the coefficients and the constant from standard form. Alright, so today we're going to start by just looking at a few examples, and we're going to decide whether or not we can use which method, and then we're going to solve it. Okay, so let's look at A. First off, is this factorable? So let me just start factorable? Question mark? If it is, then we'd need to figure out what are the two things that multiply to 10 and can add to give us 18. Okay, so think about that for a second. The only thing that can multiply to 10 are 1 and 10 and 2 and 5, and neither of those could add up to give us 18 no matter what. So this one is not factorable. Next would maybe look and see, can we use square roots to solve? Square roots to solve. And here would say no, because there's two x's, or there's two terms with x's. So here's one, here's another term with x's. So we can't use square roots to solve. Okay, so we can't use that. Next thing would have to be complete the square. And we're just going to say yes, and we'll talk about why. Okay, so to complete the square, it works well because a equals 1 and b is even. Okay, so we're going to give that a try. See if we can get it to work. So to complete the square, again, we're literally trying to make this be a square. This is like the area, so all of that stuff needs to go inside this box. So x squared is just x times x, so that's a perfect square. We need half of the middle term on both sides to make it be a perfect square. So this would be x plus 9 and x plus 9. And then to complete the square, we multiply these together to give us 81. But we don't need 81, we need 10. So we need to add or subtract something to it to give us 10. Again, one way to do that is just subtract what completes the square. So subtract 81 from it. So we go 10 minus 81, and we get negative 71. Okay, so we can write it as, or we can complete the square, so we'll write down our equation x plus 9 squared plus, not plus, negative 71 is equal to 0, and then we'll use square roots to solve. So if you complete the square, you're also going to use square roots to solve. So we'd add 71. Okay, I'm just going to move this over a little bit. So we get x plus 9 squared equals 71. Then we would square root. And then last thing would be to subtract 9. Again, the square root of 71 is prime. It can't be simplified, so that would just be our answer. All right, next, we need to figure out which method works here. So factoring, question mark. So we know if we're going to factor, we need to always take out the greatest common factor. So we should factor out a negative 1. So we'd get negative 1, and then x squared minus 10x plus 24 equals 0. Okay, nice thing about that is we'll be able to use the shortcut if this is factorable. So again, we multiply the first and last term. So what multiplies to 24 and adds or subtracts to give us negative 10. So I think how that could work would be 4 and 6, but both negative. So negative 4 and a negative 6. And then we can use the shortcut. So we'd have that negative already, and then x minus 4, and this comes from here. And then x minus 6 equals 0, and then we use the zero product property. So remember, if we have two things being multiplied and it's equal to 0, then either this needs to be equal to 0 or this has got to be equal to 0. So x minus 4 has got to be equal to 0, or x minus 6 has got to be 0. And we can just add 4. So one of our solutions would be x equals 4, or we could add 6, and our other solution would be x equals 6. All right. This one we could also, so we're going to write that down as factor y, because we can factor it. We could find the two things that multiply and add. Okay, just for the sake of time, I'm just going to not write that, but you could write it down if you'd like. All right, we could also complete the square if you wanted to. But again, factoring is quicker, so if you can find it factoring, then just do that. All right, next. Here, straight up, I know that there is only one x and it's being squared, so I think the easiest way to do it is to use square roots to solve. So use square roots to solve. Why? Because we have one x and it's squared. So here we'd do the opposite of PEMDAS. We would add or subtract first. So 2x squared equals 16. And then we would want to divide both sides. And then we would square root both sides. Don't forget the plus or minus. And then we'd simplify the root. So 2 and 4, 2 and 2, take out a group. So 2 square roots of 2. That's be our two solutions. So again, that didn't take very much time. So I think we're just trying to maybe to minimize the amount of time it takes to do these problems. Again, I think you could use complete the square for all of the ones that we're doing today, although some can go a lot quicker if you realize that it's factorable, or you can use square roots to solve. So for each of these first problems, we're just going to look at that and say, which method would you think would work best? Okay, it may be able to be done multiple ways, but again, I think we're trying to figure out which is the fastest way. Okay, so this one I know right away is that we can complete the square because A is 1 and B is even. But that might not be the fastest way. So just for factoring purposes, we're going to see, can you multiply to 8 and add or subtract to give you -6? And you can, right? So -2 and -4 would make that work. So here I would say factor. I think it would save you some time. Next, we wouldn't want to complete the square because b is not even. We have two x's, so we wouldn't use square roots to solve. So here my thinking is we would factor. So let's see if we can multiply. So it needs to multiply to 24 and adds or subtracts to -11. So maybe 8 and 3. So -8 and -3. We can't use the shortcut, but we can use the box. And again, we don't need to solve this here, but we would want to factor. So there's two examples of factoring. C, square roots to solve, because we have 1x and it's being squared. So square roots to solve. Okay. E below it, same thing. So this would apply to both C and E. D, first off, no matter what, we need to move that 20 over. So that would give us 35. And then we need to figure out what methods could we use. I know we could use square roots to solve, or sorry, I mean complete the square, which is probably what we're going to need to do. Can we find two things that multiply to 35 and give you add to 12? I don't think so. So things that multiply to 35 would be 1 and 35. 2 doesn't go into it. 3 doesn't go into it. 5 does. 5 and 7. And I think that's it. Oh, 5 and 7. That could work, right? So again, here we saved a lot of time. We could just do x plus 5 and x plus 7. Let me double check. Oh, and they both need to be negatives. Okay, so factoring works great there. And that's what I would do. And then F, we would need to move that 5 over, and that gives us 12. And here I know this isn't going to work with factoring. Okay, there's nothing that multiplies to 12 and adds to give us 14. Okay, so here we would need to complete the square. Okay, all right, and then on your homework you're also going to have some problems too where I'll ask you to solve them. Again, you can choose what method you'd like. If you want to use complete the square for all of them, go for it. There will be some problems on your test that will ask you to do it in certain ways. So there'll be a problem that says you have to use factoring to do this problem. And there will be ones that ask you to use square roots to solve, or complete the square. Okay, so just keep that in mind as you go along. So we're going to do these 4 together. You're welcome to pause and give them a try first if you'd like. So here we have 1x that's being squared, so we'll just use square roots to solve. So we would subtract 25. So x squared equals -25, and we'd square root. Super easy. just realize that we have a negative inside of our root, so we'd get plus or minus I, or I guess 5I. Okay, so the square root of 25 is 5, and the negative inside gives us an I. Alright, so here's another example. Make sure we get everything on one side, so that would give us negative 15. Okay, and then let's see, can we factor here? So let's try. Is there something that multiplies to negative 15 and can add or subtract to give us 16? And this is one a lot of people struggle with or forget, is the factor pair of 1 and 15. They just both, let's see. Let's see. So I don't think this would work, right? Because they would one would be to multiply to negative 15, one would be negative and one would be positive. So here I don't think this would work. I don't think factoring would work, right? Because to give you 16, they would both need to be positive, 1 plus 15. But that can't multiply to negative 15. Okay, so I don't think we can factor here, but we do have a equals 1 and b equals even, so we'd need to maybe use square roots to solve. So we've got x squared, and then half of 16 is 8. This is x and x. This would have to be 8 and 8. This would have to be 64. But we don't want 64. We need it to add that up to give us negative 15. Okay. So, again, kind of like a little trick here is we could subtract 64 from that, and that gives us negative 79. So we can complete that square. X plus 8 squared minus 79 is equal to 0. And then we would just need to solve. So we'd add 79 with square root both sides, plus or minus. I don't think that the square root of 79 can be simplified, so we'd just leave that, and then we'd subtract 8. So this would be our answer. Okay, so when we find these two things that multiply and add, the reason why we couldn't find that is because those are those two things that could multiply and add. And heavens, you wouldn't want to do that. Okay, I couldn't find that by just looking at it. Okay, so here's a couple other examples. Add 3. So that gives us, oops, I don't know why I did 30. Because that's what it adds to. So it adds to 30. Okay, so I think this will be nice. It needs to multiply, try factoring, multiplies to 30 and adds or subtracts to give us negative 13. So they'd probably both need to be negative, and we could do 10 and 3, right? So negative 10 and negative 3. And we could use the shortcut because a is 1. So x minus 10 and x minus 3, and then find our solutions. Again, what makes that be 0 is if x was equal to 10. And what makes that be equal to 0? Well, x would have to be 3. Alright, last but not least, again, everything needs to be on one side. So we'd subtract 10x. 2x squared minus 10x plus 12 equals 0. We could try factoring, but we'd maybe want to take out a 2 first. Okay, so we need to find two things that multiply to 6 and adds or subtracts to give you a -5. So for 6, we could do 1 and 6 or 2 and 3. So both of those can give you 5. We just need to look at the signs. So maybe I think we'd have to do -2 and -3, because when you multiply them, they have to give us a positive. Okay, and again, we can use the shortcut. So 2x minus 2, x minus 3. Find our solutions. So what makes that be 0 is if x equals 2, or what makes that be 0, x would have to be 3. Alright, so that's it. Hopefully that was okay. Again, if you have any questions, please let me know. And we'll see you later.